Hola, ¿cómo está? Let's try this in partial derivatives. So let's try to work out this example. So consider that f of xy is equals to 2y divided by y plus cos x. And then you are required to find the derivative, the partial derivative of this function with respect to x, and then again with respect to y, and you can sum the two when y is equals to 1 and x is equals to pi over 2. So let's get started. We have the function is this one, 2y divided by y plus cos x. Now let's start by differentiating with respect to x, which is the f of x. Now, if we have the 2y divided by y plus cos x, this is actually the same as 2y multiplied by 1 all over y plus cos x. I just want to simplify it so that when we are working out, it's simpler. Now, this again is the same as 2y multiplied by 1 into y plus cos x power negative 1. Yeah, and this again still is the same as 2y multiplied, or into brackets y plus cos x then power negative 1. So this the 2y into y plus cos x into brackets and then power negative 1 is exactly the same as 2y divided by y plus cos x. We haven't done anything. I just wanted to simplify it further so that it's easy to work out the partial derivatives. So now when it's like that, now let's get started. 2y into y plus cos x power negative 1. Now let's start with f of x. F of x with respect to x. Now these are two terms. We have the first one, which is 2y, and then the second term is all that. So in partial derivatives, we start with the first term, differentiate with respect to x, and then the result that you get there, you multiply by the second term the way it is, plus the first term the way it is multiplied by now the derivative of the second term. Yeah, so when we differentiate 2y with respect to x, we don't have any x there, and therefore that one will be an automatically a 0. We are going to get a 0. Why? In 2y there is no x, but we can introduce an x, and if we introduce the x, it must have a power 0, because remember, anything raised to power 0 is equals to 1, and therefore even if we introduce an x power 0, the 2y still remains, the result still remains to be 2y. If we differentiate this with respect to x, we are going to get this is the same as 0. The 0 that we have there, you bring it down, and then you have your 2y x power 0 minus 1. Yeah, without doing anything further, if you multiply anything by 0, you get a 0. And therefore, whenever you see any term and you are differentiating it with respect to something that you can't see it there, you're differentiating it to a variable that is not present in the term, then automatically that one becomes a 0. And therefore the first term becomes a 0, and then we multiply by 2y plus cos x power negative 1 plus, now we come to the second term. When we differentiate the second term, it means we are holding the first term as constant. So we are going to have 2y into, when we differentiate now the second term, we do it in 2 steps. First of all, we take the power down, whatever is inside remains the way it is, and the power up there, you subtract 1, the normal way that we do derivatives. Then after that, you come again inside, differentiate what you can see inside, term by term. inside we have a y plus cos x. So we are going to differentiate y with respect to x, and again differentiate cos x with respect to x. I hope I'm clear. All right. So here we are going to have -1 into y plus cos x cos x power -2, because it's a -1 minus 1. So we get a -2. And then again, we multiply this by what is inside now, y plus cos x. We differentiate with respect to x. Y with respect to x is still the same as the way we've differentiated 2y, and we've gotten a 0 because the variable x is not present, and therefore we get a 0 there, plus what is the derivative of cos x? The derivative of cos x is equals to negative sine x. Yeah, if we simplify this, of course, this one becomes a 0 because it's a 0 multiplied by all that. So we get a 0 plus 2y into, we have a -1 into y plus cos x power -2. And then we have this minus sine x, okay? All right, so I want to change this to a positive thing, because we have a -2, the power which is negative. I want to change that to be +2, and the only way to do that is to make this a fraction. Yeah, so this is equals to 2y multiplied by -1 all over y plus cos x power 2. That is just the same, only that I wanted to change the power to positive. And then we have a negative multiplied by a minus sine of x. Yeah. This is equal to 2y multiplied by -1 multiplied by minus sine x. We get 2y sine x divided by y plus cos x power 2. Okay, this is our f of x. So basically our f of x is equals to 2y sine of x divided by y plus cos x squared. Now we have to find f of y, and then now we can add the two. So our function is still the same, 2y divided by y plus cos x, but remember that we had simplified this further and we had gotten 2y into y plus cos x power -1. Yeah, now we have to differentiate this with respect to y. We need to get f of y, and following the same steps, we have two terms, the first one and the second term. But remember, the second term, when we are doing the derivatives, we'll have to follow two steps. You know, the first normal step that we do derivatives, and then the second step, we have to differentiate what is inside there, term by term, what is inside, which is y plus cos x. Yeah, so let's start. 2y, when we find the derivative of this, we get a 2 multiplied by y plus cos x power -1 plus 2y into -1 into y plus cos x power -2. Yeah, and then this, we have to multiply this, multiply by, we differentiate what is inside, and we get, when we find the derivative of y, that is the same as 1 plus 0. cos of x when we find the derivative with respect to y is equals to 0 because the variable y is not present there. Yeah. And this is the same as 2 into y plus cos x power negative 1 plus 2y into negative 1 y plus cos x power negative 2, and then we multiply by 1. Yeah, so it's like that. Cos x power negative 1. This one has transformed to this. Yeah, and then the second one was 2y into negative 1 into y plus cos x power negative 2, and then there was a multiplication by 1. When we multiply by 1, of course, it will still remain to be the same. So this negative is this one, yeah. And then now the 2y divided by y plus cos x, and then the negative 2 becomes a power 2 positive, yeah. And therefore, our f of y is equals to 2 divided by y plus cos x minus 2y divided by y plus cos x squared. We can simplify this further. Simplify further, we have to get the LCM of this y plus cos x and this y plus cos x squared. And the LCM is y plus cos x squared. Yeah. So y plus cos x squared divided by y plus cos x, and then we multiply by 2. We are going to get a 2 into y plus cos x, then minus 2y. Yeah. And this is equals to divided by y plus cos x squared. This 2y cancels with that. Cos x divided by y plus cos x squared. That's the value of f of y, sorry. Now, if you remember how the question read, we were supposed to find the partial derivatives with respect to x and then again with respect to y. And once we are done with that, we can sum the two. And then we have to find the value of the sum when x is equals to pi over 2 and y is equals to 1. Now, we are a few steps closer to the final result. So we are supposed to find f of x plus f of y. This is equals to 2y sine of x divided by y plus cos x squared plus 2 cos x divided by y plus cos x squared. Yeah. And this is the same as the denominators are the same, so we can add the numerators. 2y sine of x plus 2 cos x, all this divided by y plus cos x squared. 2 into y sine x plus cos x divided by y plus cos x squared. Yeah. Hope we are together up to them. Sine of pi over 2 plus cos of pi over 2 divided by 1 plus cos of pi over 2 squared. Yeah. Plus cos of pi over 2 divided by 1 plus cos of pi over 2 squared. Therefore, pi over 2 is the same as 90. And therefore, if you find the sine of 90, this is normally the same as 1. Sine of 90 is equals to 1. And cos of 90 is normally 0. You can confirm that from your calculator. And then again, cos of pi over 2 there is equals to 0. And therefore, here we should get 2 into 1 plus 0, yeah, divided by 1 plus 0 squared. This again is equals to 2 into 1. All over 1 squared is the same as, is still 1. And this is equals to 2 divided by 1. And final answer is equals to 2. And you are done. Yeah, I hope you've understood something. Thanks a lot for watching. Kindly subscribe and, bye. Ciao.